Last Monday, we went over chapter 1, which basically retrieve, tabulate data from the website, Johns Hopkins website. It's a COVID-19 CSV file. And so we loaded that into R. And we learned to use the data frame to manage this data set. And we learned how to index, pick a relevant element from the data frame using R. And we also learned how to handle the date or date time object in R. And we also learned to a bit of summarize, look at the content of the data frame. So that's the brief review of last time what we learned, chapter 1. So today, my goal is to go over chapter 2. Chapter 2 will build on chapter 1, and we are going to learn so-called wrangle data frame, basically properly modify the data, make it more useful. And we're also going to learn to do simple plot. We are going to learn to recognize the hidden biases or problem in data set. We also, this is actually another lesson I wish you can remember. You never trust anything computer tell you. You always want to verify it using independent approach. So for those just joined, please sign into Socrates. Okay, so those start, I think the last one is probably one of the most important lessons. You never trust what the computer tells you. Always, at least using two independent methods to verify it, or at least think about it. If you cannot, like you look at the results, see whether it makes sense or not, what the problem can cause it. Always think critically about the result. Okay, so those are the learning objectives. And let me see, make sure people have signed on a Socrates. So, okay. So
I have a question.
Yes.
So the past 3 classes, I haven't signed into this at the beginning of the class. Does it affect you somehow? But I sign afterward.
Oh. So you missed the 3 classes, you were saying?
No, I haven't missed the classes, but I haven't signed into this at the beginning of the class.
Okay, that's kind of disappointing because I use this for the interaction, right? So I ask you a question, you need to answer. This is just my way to measure your participation in the class. Yeah, so please sign and join the Socrates survey. So yeah.
I'm saying that for the role, like if I attended classes, but I haven't signed up at the beginning of the class, but I answer some of the question during the class.
And then
you know what I mean?
Maybe we should talk it after the class because this is basically in-class participation. So I asked you a question. I'm not sure how you answer the class question without even signing in because it does ask you to sign in your name. So let's talk about that later on. But you are supposed to sign in and participate in the class discussion. So
okay.
Okay. So this yes. Are you recording? I believe I'm recording. Am I recording?
Yes.
Yeah. I think it's a recording. Yeah. So. Yeah. Okay. This is just how I have a sense whether you are working on your homework assignment. Hopefully, let's say there are 33 students on the roster. There are only 23 right now answering the question. So there are some students not here. So.
Hey, Dr. Chen.
Yes.
Aside from the introduction to R module, what has there been another learning module assigned?
You should check your cameras. Always check your cameras for homework assignment. Right. So if you go to your cameras, if you check the calendar, you will see there's a new assignment due on September 1st.
Okay, great.
And then there's also a YouTube self-introduction due in about 5 days. So,
Okay, great. Thanks.
Yeah, you should always keep track of the assignment on the Canvas side. That's how we that's why we use the UTC Learn site. So,
Of course.
yeah. Okay. Okay. Yeah. Hopefully, yeah. For those students who are not in class, it's really hard for me to keep track of them. So, but for the it looks like at least all the students here are working on the homework assignment. That's good. Okay, this is interesting. So even though many of you have been working on the homework assignment, it doesn't seem you know how to get your certificate. How many have you have seen your certificate? It looked like 90% of you have finished the course, but not all of you actually know how to get the certificate. So this is something I'm quite feel. So the certificate is something look like the picture here. That is something like this. Once you finish an assignment, you should get the certificate. Like for when you finish an introduction to our assignment, you should get the certificate. So, and this is just for participation. I'm not using the actual score to give you a grade. As long as you complete it, if you finish the homework. So, oh well. So almost 1/3 of you haven't. So you should try to get your certificate. If you have not get it, in some case, I see one or two students think they finished it, but they have not. So, okay, so that's something you should work on it. 1/3 of students need to work on it. So,
Dr. Chin, we still get the certificate accomplished to our email ID. So we can, even if we forget to see that on the data camp, we still get the certification to our email.
Sure, yeah, you can. If you receive one from email, that's fine. As long as you have evidence you completed it, right? So I need to see your name or username and the assignment you completed, right? So that's all I need. So. Okay, this is also for me to get a sense how many you have the R and R Studio installed by now. So hopefully we see 100% here. That said, only 23 out of 33 students. So for all the students here, I hope it's 100%. Yeah. So. Okay, that's good enough. Yeah. So apparently, if you haven't even have our student installed, it will be really hard for you to follow my lecture, right? We do hands-on exercise. We do the R coding in class live. You really need to have an R student installed.
Dr. Chin?
Yes.
When installing packages for RStudio projects, if we're prompted to install the packages that need to be compiled from alternate sources, should we select yes or no?
You should select yes. Yeah.
Okay.
It also depends on your platform.
I read that we need our build tools.
Yeah, if you have trouble, then yeah, sometimes I also have trouble to compile some special package because they need some special compiler. Every now and then you do running in the problem, but trying at least in this course, hopefully we won't run into those problems. So
thank you.
Yeah. So I know in some old versions, sometimes they will have a different Fortran or different C compiler. Sometimes you do run into problems, but in that those problems become less and less frequent in recent years, unless someone using a very, very old computer. But in recent years, that haven't been a problem, have been a major problem. And if anyone have trouble to install some package, let me know. maybe, or actually the best way probably to Google to see whether you have a system incompatibility or problem. Okay, that's good. Okay, this is also for me to get a feeling how much you have learned from last lecture. So how much, after you finish your homework, and how much you have returned, how much information or knowledge you have returned in your memory. So if you are giving, if we have a data frame called TB, how would you find out what are in row 100 or 105 and column 5 and 9, and just put your answer in the survey, and then I don't have to have everyone answer, just a few of them should be good enough. Just see how many of you have. Oh, very good. Actually, no, that's incorrect. That's also incorrect. Incorrect. Oh, okay. That's it's not completely incorrect. It's close, but not perfect. How about that? Yeah. So. This is the perfect answer. Very good. So that's actually is the perfect answer. Yeah. So there. So you need to concatenate the two row number because they are gap in between. So 100, 105, and then 5 and 9. So very good. So this is the perfect answer. Very good. So yeah. And the other answer I wouldn't say it's wrong. It's can be improved. How about that? Yeah. So you make it, if this really, then you'll get some partial credit for it. Because this means 5 to 9, that's 100 to 105. So you are getting some extra information there. So okay. Okay, very good. That's good enough. So and then, okay, how do I, why is not responding? Okay, for some reason I cannot advance the question. Okay, this is somehow my mouse is not working. Something went wrong. Okay, how did that happen? Okay, this is okay. Oh well, now that the error passes, let's look at the next question. How do you find out the first few rows of a data frame called TB? So. Oh, very good. Yeah. Oh, I just randomly click maybe. Okay, those are all good. But actually, this one is wrong. You are looking at second column. So, yeah. No, that's look like a Python, and this is R. That's actually look like a Python command. Yeah. The one I'm highlighting, that's the student a bit confused with the mixed up the syntax of R and Python. So this is again, this is also Python. Yeah, but this is R. Did I say? Well, I didn't explicitly say what's in R, but we are in this today. We are discussing about R. Sorry. Okay. So, what is the usage of pound sign in R? This should be a simple question, I guess. Comment, yay, okay, good enough. Let's move on to the next one. So, what is the usage of dollar sign in R? Not all column, variable, picking up the variable, yeah, very good. So, yeah. Well, not all values, that's also kind of ambiguous. All variables are certainly wrong. All value of a particular variable, that's actually will be a correct answer. So yeah. Okay, so it looks like this dollar sign is something we need to work on. So, okay, remember last time we when we look at the COVID-19 cases at Hamilton County, Tennessee, we found August 22 to 23rd, we found 0 cases. What do this mean? In fact, this time I actually found out that the website of Hamilton County Health Department, the answer is there on the website actually. So there, I'm trying to put that answer right here. So there. The tables, graph, maps below will be updated Monday through Friday only, excluding holidays. That's the answer. So, yeah. Hold on. Let me see what unupdated information. Do not have that information. It was a weekend. No. Yeah, basically it's a weekend. Nobody is working on it. So there, and that's actually comes back to one of the lesson objectives. There are hidden bias in the data set, but just because we have a data set this is 0, doesn't mean it's actually really 0. It's just because there are some other issues we need to consider. In this case, it's the human behavior or work scheduling, those kind of things. How the data are gathered in this one. Okay, so now let's come back to. It looks like many of you had a good retention of the skill we got last lecture. Let's move on to today's chapter 2. So last time, all we did is looking at the cumulative cases at Hamilton County, Tennessee. And today we are going to look at the daily cases and how every day those COVID-19 cases change over time. Okay, please mute your microphone. I heard people's noise in the background. So, okay, so what we are going to pick is Hamilton County, Tennessee, US. And that's basically how the Johns Hopkins data set uses a combined key. So if we go back to the there, that's basically the combined key. Right? Hamilton County, Tennessee, US, that would be the combined key. So, okay, so we are going to pick Hamilton County, Tennessee. Oh, how many? Let me take a survey again, make sure everyone is on the same page. So the question is, whoops. The question is, have you opened the RMD file in the RStudio? A is yes, B is no. The question is, have you opened the RMD file in RStudio? A is yes, B is no. Oh, very good. So majority of you, okay, then let's move on. So, okay, so, and this cell, I basically loaded the Johns Hopkins COVID-19 data cases again, just so even though we spend the entire lecture on this, it's actually, we can just get it done in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code. So that's actually basically what we went through last time. So we run this and then basically repeat all the chapter 1 work. So, okay, so this may take about 30 seconds, hopefully. Well, it depends on your internet speed, but Chattanooga, we claim ourselves called Gig City. Hopefully it's faster, at least faster than average. So, well, it is certainly taking longer than I expected. So. Okay, yeah, it's done on my side. Yeah, so I didn't count how long it takes. It looks like longer than 30 seconds. Okay. So there, I have the data now. In fact, if I change that into tb.sub, so that's tb.sub at there, tb.sub. There, that's the Hamilton County, Tennessee. We have it. So, there, Hamilton County, Tennessee. And how long did we use? We picked 550 days window to today. So that started from February 22nd. It's actually still 0 cases at that time. So we could even using a shorter time window. So. Okay, so those are cumulative cases. How do we convert the cumulative accounts into daily account? Basically, we need to count the difference between every row in the data frame. So we need to, what we need to, so the, because they are all 0, so it doesn't, it's not very informative. Let me pick 90 to 100. Okay, so so from the 90 to 100, now we have those. So if I use the differ and then put 100, let's see, 425. So 425 and 460, what's the difference between the two? 43. Okay, that's good. 43. So 462, 511. Is that 43 again? It doesn't look like so. Yeah, 43. 511 and 552. 41. Okay. So basically, you can verify whether this is correct. Right. So this, and let's look at last four. Oh, that must be again Saturday and Sunday, I guess. So 794, 794, we have 0, 0. Right. So okay. So again, this is again to visually verify, make sure we know what we are doing. Even though I give you the code, you can write. You never trust the well. You shouldn't. I was going to say never trust. You shouldn't always blindly trust any code, right? So I guess there's a reason why is that because you even for Boeing company, their airplanes still have the software issue after many years of testing. Right? So the code, I spend hours on this code, but still I'm a human. I think I made many mistakes. So there must be mistake in this code I'm not even aware of, right? So you always double check, right? So, okay, so so now we are going to use that differ function to we use that differ to convert the cumulative cases into the differences between every row, and that basically is the daily cases of COVID-19. Now there's a problem here.
Excuse me, Dr. Chin. I have a question here. So the link to the data that we use is like dynamic data. It just gets updated every day. So
yes, that's precisely the reason it is updating every day. Yeah. So yeah. This is a live analysis. So tomorrow you will have extra data point. Yeah.
So I have a question here. So how do we do like for a static data? Say like I download this and then should I have the data sheet in the same folder as my code or
no?
file?
This we didn't download this data. We read it directly from the website. We do not have a local file. You could save a local copy. But my code did not because for this exercise we did not keep a local copy of the COVID-19 data set.
Okay, thank you.
So if you want to save your working document, save the binary RStudio project environment, it is actually there in the memory, right? So here. That's in the TB. If you save the entire working environment, you will have that saved as a binary file. You could save this file. Yeah, so. But we did not save that. Yeah. Although if you want to go ahead, you can figure out how to save it. It's actually just save an Excel file, and we use a tidyverse. But for the time being, we did not. I did not bother to save it. So.
Thank you.
Yeah. Okay, so I see some question about the assignment. I'm going to go over that later on. So for the assignment, always use the canvas as the reference. So you need to submit your assignment on canvas. So, okay, so now the problem when you calculate the difference, if I have two numbers, what's the difference between that? It's just one number, right? So the difference between 1 and 5 is 4. That means there's a dimension change, right? So if I have 100 rows, I calculate the difference, there'll be 99. Am I making sense to you? Right. So if I have 100 number, what's the difference between that 100 number? It's 99 gaps between that 100 number, right? Right. If you have 3 people, what's the gap between that 3 people in a line? It's 2. So if we calculate daily cases from the cumulative number, we're going to missing 1 in the row number. If I put it back, so this is why we put an extra 0 at the front. So because after we calculate the difference between row, we're short of 1. We need to put a 0 back. So that's what the concatenation of this 0 does. Otherwise, the dimension won't match. So this is clearly a technical detail, but if you don't do this, your code won't run. It's just going to say it's a mismatching of the dimension. It's not going to work. So yeah, and in a way, that's I don't think there's a problem on R. Almost every computer language is very strict on the syntax, right? So if it doesn't match, it's just not going to work. So yeah, okay. So once we have matched the dimension, I'm going to put that back into the data frame. That's just because the difference doesn't output automatically as a data frame. It's actually returned as a vector. So the local daily cases, if I, oops. There, the local daily cases actually is not a data frame, it's the vector. The data frame is actually there. The data or data frame is at the top. If you see my mouse is circling, that's our current working environment in RStudio. All the data frame are at top at the but all the vectors or single variable values, those are at the bottom. So those are the values. So after the calculation, the local daily cases actually is a vector. In fact, you can tell it's vector because I use the concatenate C here. So this is a vector, not a data frame. So I do a cast, cast it back into data frame, and then we can manipulate. Yeah. So, yeah. And then I put the date back. So the date is basically the row name, the row name from the previous table. So after I put the row name as the year, month, and date. So we start from the 2020 February 22nd. So. And this is tail just to verify the result. So here we have Hamilton County, Tennessee daily result. This is interesting. So on Monday, remember when we check, we see 20. Monday is August 23rd. Today is, yeah. So that's what we check. But on Monday, the reporting is 792. So what this means, they put that to Saturday and Sunday all to Monday. So basically that number seems to be 3 times higher than average, right? So there, that's so we see 20, that's under reporting. We see a very high number, that's the, what's the word, over-reporting. Yeah. So there, that's the, clearly is a problem if you don't know, if you don't count this weekend people working behavior, then you will run into problems to interpretation of the data analysis. So in a way, if you just look at the data itself, it's really hard to tell, but we have extra information to interpret that. So the human behavior certainly is not in the data, but it's something we should be aware of. In fact, we can, if we go back to the Hamilton County, there, it actually says they only work on Monday to Friday. If actually Monday to Friday is a holiday, they also don't work. So, and this actually happened in some time. I think there will be President's Day, there will be Labor Day, also. There's a lot of holiday actually in the middle of the week, and that actually can give some really weird result if I'm not paying attention. If you look at the mobility data, at one point I look at one mobility data in the middle of Monday, I forgot, Monday or Tuesday. A lot of people go to the park. I was wondering, and then someone reminded me, oh, that's the federal holiday. So yeah, that's explained. So, yeah. Okay, and we can also verify on the Hamilton County is 275. Oh, that's actually today. But on the Johns Hopkins website, it's not updated yet. It's only yesterday, 214. So hopefully, if you run this code tomorrow, maybe it will update, hopefully. Actually, the Johns Hopkins site should automatically update every evening. That's my understanding of it. Okay, so let's see. So this is our daily cases. And then we're going to do the using ggplot to plot the daily cases. Yeah. So remember the ggplot is additive. So we have the TB daily sub, that's the daily cases. And we have the dates of the year, month, and the date. That's Y, that's X. And then we have the daily cases, which is the first column. Because it's so long, I just use the indexing, the first column. And if I just run that line directly, that's actually put into a variable called Myplot. Because the ggplot is additive, almost like a 3D printing, you add it on. So that's just my base, and then I added the shape, geometric shape layer, and then I added a smoothing line layer, and then I added a title, I did the X label, Y label, sorry, and then X label. So this now looks a bit more presentable plot compared to the plot last time. This is actually it's similar to some plot you will see on a website. Right? So this is we start that must be February. It looks like every 5 months or 6 months in between. So, and this is most recently, it look like the cases actually is almost the same as the winter. It's actually much higher than last summer for Hamilton County. And I guess because most people now are vaccinated, so hopefully the hospitalization rate is down. So this is just cases, remember. Yeah. And on the there are also morbidity data we have analyzed. So if we hopefully if we switch this into a morbidity or mortality data, that trend is going down. But just look at the cases, it looks like currently is going up. It's almost at the same as the winter peak. It's actually much higher than last summer. So last summer we have many things are offline, and I don't remember. Do we have an in-person class last fall? It looked like it's pretty low. We don't have in-person class last fall.
No, we didn't.
No.
Okay, yeah. So okay, well, so it's actually not that bad, I guess. It's not everything seems to be normal. Yeah. Okay. So now for the exercise, what if we want to look at a different county? Let's look at the inside of Hamilton County. How about we look at the?
Excuse me, Dr. Chin. I have a question on the plot.
Okay.
So on the axis, so why is the 0 on the y-axis? Why is the 0 not as same as the date axis? Why do we have like a small gap in there? Like there is a negative number?
Why is it a negative number? You should ask your Hamilton County Health Department why there is a negative COVID-19 case.
Dr. Chen, I have an answer for that because I'm one of the few people that manage the county data. That was a day that we did data cleaning, and so we had a backlog of cases, and there was a negative number.
Oh, who is this?
Megan.
Who?
Megan Sloan.
Oh, thank you. There. I didn't know we have an expert here to explain that. Thank you. Do we have some other inside information to share?
We do work 7 days a week. We work on the weekends. We just don't post on the website on the weekends, but we do.
Oh, I see. Okay. My apologies for saying you don't work on weekends then. Sorry. Okay. Thank you. This is quite interesting. So yeah, so basically, by the way, this is not unique to Hamilton County, Tennessee. In fact, if we go back to the Johns Hopkins data set, for every state, there will be a special county which belongs to nobody. That's just a so-called holder space to put all the COVID-19 cases in that state, but no county want to claim it is theirs. This actually, for example, on the cruise ship, there are people got COVID-19. Who do they belong to? No state want to claim that's their COVID-19 cases, right? So the cruise will become a special place. There are also the so-called federal prisons, and the state doesn't want to say that doesn't belong to us. So the many federal prisons are also counted specially in the data set, because the county health department say no, that doesn't belong to our data. Unfortunately, that's some really weird way how the data are collected. Obviously, they belong to the United States data, but if you really break it down into a county state, there are cases nobody say belong to them. So it's actually quite interesting when you look at the original data. So yeah.
So Dr. Chin, I have one more question here. As part of like data pre-processing, don't we check the 0 values of in the cell numbers, and then don't we work on like removing those data or making some calculation so that they match with the numbers that's almost near to that, like using a mean or average?
I'm actually not clear what you are trying. It really depends. 0 could be just 0. In this case, there are 0 cases. That is valid, right? For example, if you go all the way back to 2019, almost all states are 0 cases. That is the correct value. So I guess maybe I didn't understand your question exactly. Yeah, but in this case, 0 could be correct value. So,
Okay.
in recent days, if you really see a 0, you put a big question mark on it. Right? So,
I think what she's asking is sometimes if the data is empty, you put the previous data instead of it.
I think she said sometimes the data is empty. But... Oh, you mean whether you put it when you do the well, if you look at the smoothing line, we are trying to do the analysis, smoothing it out. It also depends on the question you are asking for, right? So if you, it's a good question. That actually means how do we make meaningful estimation or inference from the data, right? So if you want to calculate the so-called transmission rate, in virus, that's called reproductive rate. Let me see if we are a bit ahead of us, I guess. The basic rate production. Okay, effective. Oh, why it gave me a UK site? I'm trying to Google for a Wikipedia site. There, basic reflected number. So if you want to estimate the basic reflected number, and there's some noise, the high number, that's actually is considered in part of it. So those number doesn't count based on the absolute number. So it's a continuous model. So it depends on how the analysis is done. Yeah. So if you want to estimate 80, that's actually considered a part of the is already there. So we don't have to smoothing it again. Although in theory, if I think smoothing it shouldn't change the reproductive number estimation, because that basically is the smoothing itself. So it also depends on the window of the time how you smooth. So if you want to smoothing between days, right? So Monday, Tuesday, you smooth it. But if you want to smoothing on a week, then it clearly will skew the data, because the SARS-CoV-2, the reproductive rate is 4 to 5 days, right? So if you got longer smoothing, and then you will obscure the actual inference, right? So I guess my answer is it depends on the question we are asking or we are investigating. Yeah. So.
Yeah, that explains. Thank you.
Yeah. Okay. Good question though. Although it's way much ahead of our learning objective, but it's actually I was trying to plan to calculate the RT maybe in another 2 or 3 lectures, but it's good that you already mentioned that. Yeah. So. Okay. Again, I want to keep this interactive. So let's. What other county we want to work on? We look at Hamilton County. What other county we want to compare to? I have some example here. I mean, we can compare with Texas. who do we want? California or San Francisco? We can compare with Cobb County, Georgia. That's closer to us, right? Let's compare with Georgia. How about that? Let's see Cobb County, Georgia, U.S. How about this? That's where you're from. Oh, welcome to Tennessee. So, okay, let's look at the hometown of David. David. Okay. All right. See, let's see Cobb County, Georgia. And the good thing is now we have the R code. I could just run the entire thing, chapter 2. Okay, let's see. Oh, sorry. Someone actually said we should study real New York. You know, hopefully in 10 minutes, but let's Let's look at the real New York. Is that a county? RHEA, is that a county? We can only look at the counties. This is what the data is based on. Okay, Cobb County, Georgia. Cobb County, Georgia is probably very similar to Hamilton because we are so close to each other. So. And that's the cumulative.
So Professor Chen, you can do the little drop down arrow too, right? If you wanted to just do all the chunks above.
Yes, I guess I don't want to run chapter 1. So I could go all the way to the end and then just do, yeah, I can. That's a good suggestion. Let's just run all previous one. That actually will be, yeah, all chunk above. So I'm going to go to chapter 3 and then just say, run all chunk above that we finish all chapter 2. So, okay, so let's just run all chunk above, finish the chapter 2. So.
So I've looked at several counties and they all seem to have that spike or a pretty high dot on 2021-01. And I'm guessing that might possibly be due to New Year's Eve and people getting frustrated.
Holiday, the winter peak. That's what we call the winter peak. Yeah. So that is I guess a general case in the continental U.S. Yeah, so. Although if you really, what you can do is you should write a batch processing, do it for all the country, and then compare their profile, and we can actually calculate the so-called Hamming distance of pattern matching. So that's a bit more. Much more than we are doing now. So if you really want to compare the trend from county to county, we can actually do that numerically. So yeah. Okay, is it done? Yeah, so this should be Cobb County, Georgia. Looks very similar to Hamilton. So although I have to say, I don't see a big negative number somewhere. Yeah. So you look at their reporting is more consistent. Remember in Hamilton, we have a big negative number somehow there. So, but Cobb County seems to have a more clean reporting. So good for them. Yeah. So they don't have a big job, but somehow reporting a negative case. So there. But you can see their number, I guess their population must be much higher than Hamilton. Their daily cases seem to be 2 to 3-fold higher than Hamilton County. Right? Hamilton County is about 300, while this one is actually almost 1,200 there, or it's actually 4 times, 6 times, 5 to 6 times higher. Yeah. Yeah. But you can also see a general trend. You have a summer peak, winter peak, now it's up again. So yeah. So this clearly is a general trend, at least compared with Cobb County or Hamilton County. Is that a real New York? Is that a continent? Maybe we can try real New York. Yeah.
Dr. Chin, I have a suggestion. Is it possible to have 2 data sets? It's possible to have 2 data sets in one plot for a comparison.
Very good. That will be a that will be a few next few. That's actually what I'm supposed to go over next chapter. Overlay on multiple countries, but right now for today's for today's, we have about 20 minutes something left. Yes, so I guess you can try to move ahead and also look at the data camp material. You can go ahead and add more. That's actually will be next few chapters. So we next chapter we are going to add Google mobility and also get a weather condition and really do an overlay. So they are, although we are also just still looking at one country, but you could also add multiple countries there.
Okay, thank you.
Good question. And it will be more useful for comparison. If you want to compare multiple copies, will be more informative to put them on the same plot. Right? So, that will be the next few chapters we'll go through. So it looks like real New York is a county, so I'm going to change that to real New York. Let's see how it works. So. Oh, so real is also in Tennessee?
Yeah, I think that's what he meant. I think chat is in Tennessee.
Oh, but sure, we also can do real Tennessee. So. Real. Okay. I'm going to, again, just run everything above and then we'll have it. So run all chunk above. But you can see the difference between GUI interface and coding is it's very easy to repeat a code. It's much harder to repeat a GUI drag and drop, right? So writing code may seem to be tedious than GUI interface point and click, but the code will tell you exactly what to do. You can do it repeatedly, precisely the way you want it. Right? So this is the reason to actually do data analysis or so-called reproducible data analysis, you have to write code. Okay. Chapter 1, 2. It's going to, I guess it's actually, oh, it looks like I'm running more than what I did. It's actually also plotting my Google mobility data. I guess I must click check. That's why it's taking a while, because it's running all the code, not just check first two chapters. Yeah, it looks like it's actually running. This should be real Tennessee. Oh, it looks like real Tennessee almost has no summer peak. That must be a low population. How many population? It looks like it almost has no summer peak, just a winter peak, and then winter peak again. Yeah. So it looks like it's almost. Someone raise a hand. Yes, you. Is that Sean Kelly? Yeah.
Hi. Just I just had an aside question. Do you still want us to install Anaconda and the Jupyter Notebook?
That's for second part of the semester. When we work on Python, we will use Anaconda. Yeah.
Understood. Thank you.
This class is supposed to teach you two languages, R and Python. So before the middle term, we focus on R. After middle term, we will focus on Python, and then we will use Anaconda to notebook extensively.
Gotcha. Thanks.
Yeah. So so good question. In a way, I petitioned because it's really confusing between the R and Python. Their syntax are so different. I often confuse that myself. So, but that's it. Very often we have to intermingle R and Python in a real project because the R and Python good at a different thing, right? So data analysis, often you do it in R, but for visualization, automation, web publishing, often we use Python. So very often those two have to be used at the same time.
Did we use Python in computational genomics, or did we just use R?
We use both as well. Who is asking this question?
Oh, okay.
Sorry, Sean Kelly? Okay. So R and Python are good at different things. So R is good at the numerical analysis. Python is good at the text document. And when you're talking about genomics, there are also numerical data, there are also text data. So for text data, especially sequence data, we often use Python. But for numerical data like expression, copy number, or modeling, behavior, then we use R. So in practice, I sometimes even write a Python code to call R code, then return back into Python, then do something else. So yes, obviously from software engineering perspective, that's very bad because you are using something totally not optimal. But in practice, we just want to get the job done, right? So just find a way to get the job done, and that's it. So yeah, good question though. I didn't expect that come up. So yeah. And so Python is actually very useful for genomics when we have to do sequence analysis. Also, recently there's another thing we rely on Python quite a lot because the deep learning and machine learning are much more advanced in Python than in R. So for R, we do a lot of statistical learning, traditional machine learning. But for deep learning, PyTorch and TensorFlow, they are built into Python, not R. So if we want to use TensorFlow and PyTorch, we have to use Python. So that's also the practical reason why Python is also very important. So not just in biology, it's probably in many machine learning, deep learning projects. So good question. So let's give you motivation to learn both R and Python. So they are both important. So yeah. Okay, so I guess I can actually open up. It looks like this is a very simple exercise to many of you, and I hope you are not bored. Let me see. Let's open up another question. Let's pose a more challenging question. Found out some weird. How about we found some weird counties in the Johns Hopkins data set? The question is. Let's ask a more challenging question. So, found out some weird counties in the Johns Hopkins COVID data set. And you can, once you do that, you can actually put your answer. I need to open up the question. Yeah. This is not a multiple choice. I'm going to pick a short answer. Okay, yeah. So the question is, found out some weird counties in Johns Hopkins COVID-19 data set. How do we do that? Yeah. And hopefully you are not using the browser and point and click to do that. I guess my question didn't say how you get it. I mean, you could point and click and tell me what county is weird. So, yeah. This is actually quite funny when you first learn. I remember when I first looked at it, I looked at the state. I was like, oh, there are only 50 states supposedly, but there are actually more than 50 states in the data set. Yeah, I guess not just where the county and where the state, yeah, where the locations. How about that? Yeah. So.
Are you wanting just the county name, Dr. Chen?
I was hoping someone can give the R code or a few lines of R code.
Oh, sure.
Yeah.
Sure.
Yeah. How would you do that? Yeah. Oh, you sorry, what?
I've already submitted.
You already submitted? That's fine. Yeah. But I didn't say what you already submitted. Oh, that's a weird county. Okay, I guess that is a weird name, though. I agree. So East Cambria, that doesn't look like a weird name, though. Okay, I guess that's a reasonable answer. My country, see, Whitefield, Georgia. Is that a okay? That is an interesting name, though. Okay, but I was trying to see. Okay. Well, maybe that question is a bit too out of context now. Maybe it's a bit challenging. So okay, actually you can actually look. Let's. I'm not following my own advice. So let's point and click and see what other weird countries there, and then maybe give you some idea. So okay, so let's look at Alabama, and then.
Are we really doing this right now?
Sorry, what? Sorry. There. She's here. There is a county called Unassigned, Alabama. It also has a weird so-called FIPS code, 90001. But this so-called FIPS code is supposed to be something like a 4-digit something. Yeah. But apparently, this is actually not unique to Alabama. Very good. How about other states? That's probably from cruise ship, I guess. Yeah. Okay. Yeah. So, but how do you use R code to find out how many states actually have that weird counties? How do you, in fact, how many states are not even supposed to be states? How do you find that one out?
Could use the module and search for unassigned.
Could use yes, yeah, we need to use the match and string match. Yes, that's a good in a way that's probably a bit ahead of us, but you can't use just directly equal sign. Let me try this. I guess I'm trying to challenging you a little bit. It's certainly outside of this chapter now. I guess I sense some of you are really bored since it looks like this is a very easy chapter for you. so okay, let's let me add I'm gonna say this called extra challenger. Extra challenges. And this is the question is what? Find out weird places, weird locations in the data set.
Dr. Chen, do you mean like a weird name, like just that sounds strange? Is that?
Oh, I see. No, I mean, weird means it's not supposed to be there.
Oh, okay.
Oh, I see. I guess I didn't phrase my question very well. I don't really mean the name are weird. It's
Okay.
Oh, my apology. I guess I didn't realize my question is not posed very well. Thank you. I really mean weird in the data science sense, not in the English sense.
Not like subjective.
my apology. I didn't realize. I didn't phrase my question very well. I mean,
No, you're fine.
Yeah. Okay. I mean, weird in the computer science or data science perspective. So it's like it's like the weird. I mean, a number an integer is supposed to 1, 2, 3, 4, but if you got a 0.5, that would be a weird integer, right? So that's what I mean. So it basically you can consider that's an error almost as, except that's actually in the data set. In this case, you have in Hamilton County you have a negative case number. That would be weird. Basically, it's something not supposed to be in the data set. So okay, that's a good comment. I didn't realize my question itself is not that clear to you. My apology. Yeah. Okay, so in fact, we let's look at the data set.
So most of the different counties have a name like unassigned or out of the state name.
How many? Very good. So you were saying most, but how many? That's
I'm running the code.
Okay. Do you want to put your code into the chat window? So you can actually look at the province and state. What's the province and state? So if I see TB and state. Okay, so those are the unique province and state in the data set. So you can see how many do you have? 58 of them. How many states do we have? Well, this there is also a state called Diamond Princess. I never heard there is a state called that. Oh, it's a cruise ship. That's right.
Sounds like a cruise ship, yeah.
Apparently, nobody want to claim that is their state, so they had to put on the special state in the data set.
I never realized that they did that.
Yeah, apparently no state want to claim that's theirs. Yeah, so there's actually other, I believe. Hold on, let me see. There, yeah. Grand Princess. There's another one. Is that the only two? That seems to be the only two ships are there, is it? Ohio. Yeah, but I guess they are also like American Soma. Those are official. I guess territory of U.S. I guess, yeah. So, and there's also District of Columbia, which wished to be a state but couldn't get it. So, yeah. But there you see there are actually 58 states in the data set. So there, I guess there, but this is what I mean with location. Diamond Princess is actually considered as a state in this data set. And in the counties, okay, how do we find out how many counties of Tennessee in this from this data set? So I'm going to put my second challenge there. So Oops, sorry, my touch pad is too sensitive. I lost my location of it. Is that, whoops, sorry. Okay, I minimize that, so. My second challenge is found out how many counties in Tennessee. How do we do that?
Could we use the equal sign with the dollar sign?
Yeah, we can. Yeah, so TV, filter. Actually, this has to be double equal sign. That's called admin 2. Yeah. Is it? No. Southern state. There's no Tennessee. Did I have a typo? Well, I already hold on. Let me run that. How do I spell Tennessee? Oh, just copy paste that back there. So. That seems to be correct. I did type it correctly. So. Yeah, that seems to be correct. Oh, filter. Thank you. Thank you. Okay, that I have a typo there. So okay. Filter. There are 97 of them. Oh, I shouldn't use the length because that's actually a contact dimension. So I'm going to assign it TN counties. Okay, so TN counties, how many do we have? There are 97 of them. What does Google say? How many counties in Tennessee?
There's an unassigned county.
Yeah, so there's unassigned. But so there should be 96 at Tennessee counties. But there's also unassigned. Yeah, so there, unassigned is also there. So
there's 95 counties.
According to Google, yeah, but somehow 95. Okay, apparently even Google give multiple answers. So, how do I, if I don't want to count it, how do I get it? I actually could say.
You can do length and then count it, lengths, and then pass in the variable Tennessee counties.
Yeah, I actually can do the length. Actually, hopefully that works. No, one.
More than that.
Yeah, I agree. So what mistake did I make here?
Do you need to convert into a vector?
I already called that. It shouldn't be the case. I could convert that into but no, it's actually row name is not correct. Let's just call it as dot vector, as dot character.
Oh, you had two ends when you wrote row names.
Oh, is it? I
Or
see.
you can try, maybe this is like a data frame. You can try using the str and see how many entries are in the county, TN counties.
That's good enough. Okay, now it works. Yeah. Yeah. Oh, thank you for spotting my typo. Okay, so according to this data set, we have 97 counties, including the unassigned. So, yeah. Okay, it's a good exercise, I guess. Yeah. Oh, sorry. All right, so let's wrap it up. I guess this is a bit challenging. I actually run over time again. So we basically wrapping up, we processing a data frame, make it a data more useful. I guess one of the lesson is recognize the hidden bias in the data set and always verify your result. In this case, we try to verify the source of data. Right? So that's probably one of the most important lessons. Always recognize the bias and verify your result. Okay. Any other things we should go over? If not, I'll see you next time. Yeah. Bye.
Thank you. Bye-bye.
Thank you.
Thanks so much.
Bye.
Thank you. Have a good day.
You too.